All righty, so we'll get right into it. Can everybody see the slides okay? Awesome.
You can see them now, yeah.
Awesome. All righty, so my name is Alaina Woods. I am a second-year PhD student at the University of Maine. And up front here, I'd like to thank my advisors, Dr. Pauline Camus and Sandra Day Urasete Stone, for helping me through the first 2 years of my PhD, and Lee Cantor from MDIF&W for fielding all of my phone calls and questions and assisting me along the way. So tonight we're going to be talking about what we learned from the 2021 Moose Health Hunter Harvest effort. So briefly, we're going to go through some background. I'll share some preliminary results from this past year, and it's important to note that this was only year one of a potentially 3-year study. So we want to make sure that these results are just preliminary for now. I'll touch on what's left to do, and then we'll get into the 2022 hunt and the screening we're planning on doing this year. So why are we choosing to study moose? So they're an important charismatic megafauna, and all this means is that they're a large animal that everyone knows of, and everybody is aware of what a moose is and what it looks like. They're also a game animal, so they're important to a variety of stakeholders. Many of you here tonight are active hunters, and so you're a key stakeholder in the management of the moose population. They also bring in revenue and they bring in revenue to the state, not only through hunting, but through wildlife watching, as many Mainers, not Mainers themselves, they also want to see moose, but many people travel to the state of Maine trying to see moose for the first time. Furthermore, we know winter ticks are highly problematic to calf moose survival, and the winter ticks are also impacting cow moose, so the females' reproduction rate. So what's currently being done about the winter tick problem? So I just went over how it's been identified as a problem. So MDIF&W, the State Department, has been collaring cows and calves every January since 2014. And during these live capture processes, they're collecting blood samples along with outfitting the calves and the cows with collars, as seen here on the right. So through this work, we have gained information from 3 separate wildlife management districts. Animals were collared in District 8 from 2014 to 2020, in District 2 from 2016 to 2020, and starting in District 4 from 2020 on. So 2020, 21, and 22 animals were collared in District 4. Through this work, we've been able to track moose survival throughout the winter. And all of this research has led into the adaptive management hunt, which I'm sure many of you are familiar with or are participating in this year or participated last year. But what this research has shown us, the theory that is currently being fed into the adaptive management hunt, is the high population density of moose. And so high population density is a relative term. So even though we are seeing reduced numbers of survival, the population is potentially still high. This means there are more ticks, and more ticks means lower reproductive rates in yearling cows and adult cows, along with newborn calves being born underweight, and calves are struggling to survive to their first birthday. So by lowering the population density by increasing harvest permits in District 4, this would correlate to less ticks, and less ticks means higher reproductive rates. Calves are healthier and they're surviving to their first birthday. So with all this great work going on from the department, why are we testing hunter harvested animals? So some benefits of taking samples from hunter harvested moose. We can sample from quote unquote healthy moose So moose in the fall should be at their healthiest as they're coming off a full 2 seasons of forage. We're also able to increase the geographical scope of our study by surveying moose health across the entire state. We have the ability to collect tissue samples, which we don't have when we're collaring and capturing live animals. We can extend the age ranges represented as many hunter-harvested animals are past that 1 year mark. And we can gain more evenly distributed data on adults. So prior to the hunter harvest effort, the live capture work has been focused on cows and calves specifically, as bulls are a little bit harder to capture. So with this in mind, we have 3 objectives moving into our hunter harvest work. We want to expand the geographic scope of the department's ongoing work. We want to evaluate risk factors associated with parasitic infections. And we want to assess parasite effects on reproduction in cows. So many of you are familiar with this process if you participated in 2021. But for those of you that did not get to participate or are considering participating for the 2022 hunt, I want to briefly go over the sample collection process. So this starts by gauging interest. If you are a 2022 permit holder, you received an email from me with a Google Forms link. And this link led you to a questionnaire, even gauging if you're interested in collecting biological samples at all, what type, the registration station you plan on utilizing, along with other questions such as how do you want to pick up your kit? Do you want it mailed to you or do you want to arrange pickup with me? So from that form, we then select participants based on the wildlife management district their permit is for, the sex of the animal their permit is for, and if they were even willing to collect biological samples. Once the participants are selected, you receive your sampling kit either in the mail or you arrange pickup with me at either the University of Maine or you pick up at one of the department MDIFNW headquarters. And so this is what our sampling kits looked like last year. They fit neatly into a gallon Ziploc bag, so they're pretty small. It includes 4 blood tubes, these red and purple top tubes here on the left, tissue tubes and these green top tubes on the right. And so we're asking for a chunk of the tongue, which should only be about the size of your thumb fingernail, and a piece of the lung tissue, again, which should just be the size of your thumb fingernail. In the gallon Ziploc bag in the back, you have gloves for sampling, paper towels to help wrap the tubes and clean up any mess, along with a printed out sampling instruction sheet and a physical data sheet as well. This year, sampling is going to look a little bit different. We're asking for a fecal pellet and just a chunk of the lung. So those of you participating for 2022, we're swapping out tongue for a fecal pellet. So after you receive the kit, you guys get to hunt the animal, and fingers crossed it's a successful hunt and you have an easy time collecting samples. I know a big concern is the amount of time sampling can take, and it should only take approximately 5 to 7 minutes. The sampling is not very expensive by any means. So you collect these samples with following the instructions provided and the kit. And then the samples are dropped off at the registration station when your animal is tagged. So leading into this, 2021 was our first year of the hunter harvest effort, and we had a very successful first sampling season with over 210 samples returned. So this exceeded our expectations. We received almost 50% of our kits back, so that's fantastic, and we're thrilled with that result. And so this map here on the right is a map of Maine with the wildlife management districts depicted here in the black bold numbers. It is a heat map, so we're showing the number of samples collected from each wildlife management district, with the darker green being a higher number of samples, while the red is a lower number of samples. So we did receive over 30 samples from wildlife management districts 1, 4, and 5. So the largest number of our samples are still coming from the core range, so northern Maine and western Maine. However, we did expand around wildlife management districts previously sampled to create a better understanding of moose health throughout the state. So with that, we expanded the geographic scope of the department's ongoing work. And next, we want to evaluate risk factors associated with parasitic infections. So what are risk factors? These are variables that make an individual more susceptible to infection. So some common risk factors that we're used to discussing due to the ongoing COVID-19 pandemic in humans include age and pre-existing health conditions. Common risk factors associated with wildlife include age, habitat use, sex of the organism, and their reproductive status. So what is a parasite? So by definition, this is an organism that lives on or in a host and gets its food from or at the expense of the host. So some common parasites we're all familiar with include bacteria, viruses, ticks, and parasitic worms like tapeworms. All living creatures have parasites. It's a natural part of our world. And so normally when we talk about parasites, the initial connotation is that they're bad, such as this deer tick here on the right. They spread disease and they're not good. However, there are many good parasites, such as yeast that we use to make our bacteria, or our beer, and the mites that live in our eyelashes eating dead skin cells. So why are we interested in testing for the effects of parasites in our moose populations? So parasites can have drastic impacts on wildlife populations. As many of you, I'm sure, are aware, I touched on the winter tick problem previously, but winter ticks are currently reducing overwintering calf survival and cow reproduction here in the state of Maine. In 2022, we had an 87% calf mortality rate, which is extremely high. Often, wildlife population destabilizations are caused by multiple factors working together. So it's really not just a single variable that's working to destabilize these populations. It's many variables working in tandem. Furthermore, infection with some parasites can leave hosts susceptible to subsequent infectious agents. So I'm about to briefly go over some parasites your Maine moose could potentially be infected with. However, I want to preface this with none of these parasites are cause for concern to your personal health. However, we do always recommend to cook your game meat thoroughly and to the temperatures recommended by the USDA. So what parasites are Maine moose potentially infected with? First and foremost is the winter tick. So the winter tick is a one-host tick that completes all 3 of its life stages on a single animal. And so unfortunately, this picture here with the blue gloves, all of these little dots are in fact winter ticks. And we can see moose calves infested with over 90,000 winter ticks on a single animal. Another potential parasite is a bacterial blood parasite known as anaplasma. And I won't get too far into anaplasma right now, as we'll talk more about it later on. But this is a potential infectant for our Maine moose. We also have Echinococcus, which is a genus of parasitic tapeworms. And this genus of tapeworms causes cysts in the animal's lungs to form, like this picture that popped up down here in the lower right-hand corner. Also, meningeal worm has been known to be present in Maine moose. Meningeal worm is a parasitic nematode that infects the nervous system of moose and causes neurological symptoms and eventually death. Moose in Maine are also known to be infected with lungworms and muscle worms. However, it's important to note that lungworms and muscle worms are considered common co-inhabitants of moose and are not thought to cause any type of disease. However, moving forward, we're going to be focusing on anaplasma and meningeal worm. Anaplasma is a newly documented parasite here in the Maine moose, and the effects of this parasite are largely unknown. Meningeal worm is a known parasite in our moose. However, it has been hypothesized to cause moose population declines in other parts of North America, such as Minnesota. So I keep talking about Anaplasma. This is a genus of bacterial blood parasite. And so species within this genus can infect a wide range of hosts, including humans. Anaplasma marginale infection in cattle is known to cause abortion, anemia, and death. So Anaplasma also infects livestock. If you take your dog to the vet, the animal is tested for Anaplasma infection as well. So genetic work is showing that there is a close relationship between Anaplasma marginale, so the species that infects cattle, and the Anaplasma we're finding in our Maine moose. Due to this close relationship and the symptoms caused in cattle, we're interested in exploring Anaplasma infection further in our moose population. Furthermore, we're finding that animals with Anaplasma infection and heavy winter tick loads have the lowest probability of surviving the winter. So I have this lovely graph here that can look a little chaotic, but what I want to draw your attention to is this peach-colored line here on the bottom. So what this is showing, we have survival probability on our y-axis, and we have time since collaring in weeks on our x. And this peach-colored line is showing that animals experiencing heavy winter tick loads and Anaplasma infection have the lowest probability of survival throughout the winter, with about a 15% chance of survival. The animals with the next worst chance of survival, so the second lowest probability of surviving the winter, are animals infected with moderate loads of winter tick and Anaplasma infection, this sky blue line here. So we found that more than a third of the samples we tested for the hunter harvest samples were positive for Anaplasma. And so we have this graph here on the right with our percent on our y-axis and time in years on our x. The solid black line is showing overwintering calf mortality rate. And so we see here that in 2020, we peaked at 87% mortality in our calves. Furthermore, in this dashed line, we have Anaplasma prevalence. So again, we're tracking it through time, and we see a peak in Anaplasma prevalence in 2022 from our live captured animals at about 97%. If we were to plant our hunter harvest prevalence for Anaplasma on this graph, it would be significantly lower than what we found in the winter of 2021. We found an Anaplasma infection prevalence of about 93% during the winter of 2021. Well, we're seeing about a 34% Anaplasma infection status with our hunter harvested animals. Furthermore, we found that Anaplasma prevalence varied by wildlife management district. So I have all of the districts we had more than one sample for represented here. And Wildlife Management District 4 had a 35% infection prevalence. So the blue chunks of these pie charts are positive for Anaplasma, while the red are negative. Excuse me. And then we saw the highest rate of Anaplasma infection in Wildlife Management District 5, where we saw 52% of the samples positive for Anaplasma. So just to bring it back to our objective, we wanted to evaluate risk factors associated with parasitic infections. So to do this, one of the risk factors we evaluated was sex of the animal. So we did have a male heavy data set with over 2/3 of our samples coming from bull moose. We also had a wide range for age distribution, from animals ranging from 1.5 years old to 15.5 years old. However, more than 50% of our samples were from moose 4.5 years or younger. And so while this does look skewed to younger animals, it is representative of the total age range of animals taken for the moose hunt, with the average bull being about 4.5 years old. So we found no significant relationship between anaplasma and a variety of risk factors. So the risk factors we looked at include antler spread, as it is known that cervids infected with many parasites do not divert a lot of energy to antler growth. Weight of the animal, age of the animal, wildlife management district that the animal was taken in, and the IF&W region the animal was taken in. So the regions are slightly larger than the wildlife management district. So we evaluated these risk factors, even though we didn't find any statistically significant relationship between the risk factors and parasitic infection. Next, we want to assess parasite effects on reproduction in cow moose. So to do this, we use corpus luteum follicles. And so these follicles develop in the ovary of the cow after an egg is released. And this can be used as a proxy to show reproductive potential. Well, we had a small sample size of only 14 paired biological samples. So that is a blood sample and an ovary. We did find patterns such that animals uninfected with anaplasma tend to have higher numbers of corpus luteum follicles. So this means that those animals were more prone to be active reproducers. So due to this pattern that we're seeing, and even our small sample size of only 14, we are interested in investigating this relationship more through further sampling. Alrighty, so we assessed the parasite effects on reproduction in cow moose. So what should you walk away with from these results? First and foremost, 1 year is not enough data to draw definitive conclusions. One year is not enough data to draw definitive conclusions, unfortunately. Anaplasma prevalence varies across the state of Maine, but does appear to be present at a large scale statewide. Furthermore, moose are infected with multiple types of parasites that could be aiding in reduced survival and reproduction of this animal. So these are our 3 key take-homes from the 2021 moose health surveillance study. So what's left to be done? Unfortunately, I wish everything was all wrapped up in a nice bow that I could share with you tonight, all of our results. But our samples are currently being tested for meningeal worm. So as I mentioned, meningeal worm is a parasitic nematode that has a life cycle involving white-tailed deer and gastropods. So this nematode reproduces in the white-tailed deer. The animal then excretes the larvae through feces. The larvae are then absorbed through a gastropod, such as a snail or slug, through their foot, and continues their life cycle and development within the gastropod. The snail or slug, whatever the larvae have infected, then climbs vegetation where it is accidentally consumed by white-tailed deer, and the cycle continues. Moose and other large cervids can become infected with meningeal worm in the same way, from incidentally consuming an infected gastropod on vegetation. However, unlike in white-tailed deer, this nematode is unable to reproduce in other large cervids, such as moose and elk, and unfortunately causes neurological symptoms and eventually death. So we sent our samples out to the University of Tennessee at Knoxville to Dr. Rick Gerhold's lab. And his lab is currently testing the samples that were able to be tested for meningeal worms, so we can get a better idea of prevalence within our Maine moose population. Still other work that we have planned, we are planning on a genomic study to determine if there is a genetic component to parasitic infections in moose. We plan to further analyze risk factors associated with parasitic infection by incorporating the meningeal worm data. And we want to work towards understanding if seasonality plays into anaplasma infection. So there are a lot of unknowns surrounding anaplasma as a parasite, including definitive symptoms of infection. And so we're starting to work to check off some of those boxes for anaplasma infection in our moose and what is it doing. So we are excited for the 2022 hunt, and it's already well underway with lots of emails being sent out. Some exciting changes. We are increasing the number of samples we're aiming to collect from hunters. So last year we aimed for about 420. And this year we're aiming for about 500. We're also streamlining our registration stations utilized in a hope to cut back on unusable samples. So Maine is a very large state. So we're hoping to try to funnel some of the samples or the majority of the samples through major registration stations, such as Gateway and up north, where we'll be able to collect them on a more timely manner, trying to cut back on the number of unusable samples due to length of sitting out in a cooler. We also are planning on focusing some efforts on the adaptive hunt in order to get paired data for the corpus luteum count. So we need whole blood and ovaries from cows for that paired data. And so we're hoping that by focusing efforts on the adaptive hunt, we can really increase that sample size to get some more definitive results for next year. So how can you help in 2022? If you have a 2022 moose permit, please fill out the Google form. You should have a few emails from me in your inbox. And if you do have a 2022 moose permit and you end up with a sampling kit, please bring in your samples for us and also the ovaries and the tooth for IF&W as well. I do hear that they're giving out a fixed blade knife or raffling off a fixed blade knife for the ovary collection. And Lee was gracious enough to show me that knife, and it's very, very cool. I wish I had a moose permit this year to enter as well. If you are taking biological samples for the 2022 moose hunt, here are a few things to keep in mind. So try to keep your samples at a constant temperature. So we prefer refrigeration, but we understand this isn't possible all of the time in the field. But if you can have those samples avoid sitting out in the hot sun or being left in a car in the dash, anything to try to keep them at a constant cool temperature. Second, fill your blood tube 3/4 of the way up. So this allows for the clotting agent to be mixed thoroughly in the purple top tubes and also in the red top tubes. And make sure your data sheet is fully filled out with as much information as you're able to give us at that time. If you don't have a moose permit for 2022, talk to your friends and family about the research and encourage them to participate. We're also planning on hosting another webinar update for next summer. And so we hope that you guys will all join us again. And feel free to reach out with any questions. My email is listed here. I also have it listed on the question slide. So with that, I would like to thank so many people, but first and foremost, the moose hunters that participated in 2021. This would not have been possible without all of you. I would also like to thank Dr. Pauline Camus for helping me through this process, along with Lee Cantor at IF&W. He's been great at fielding all of my phone calls and emails. All of the IF&W biologists and staff who helped get the samples to a central location and who collected samples for me at registration stations. The registration station attendants, they were great in being a team player and collecting all of the samples and trying to keep them cool when they could. I'd also like to thank Tori Lee Jackson Photography. All of these great moose photos and deer photos you saw tonight were courtesy of her. And so I would like to encourage everybody to check her out as well. I'd also like to thank the Wildlife Disease Genetics Lab for all of their help. And of course, all of our funding sources providing financial support throughout this process. And with that, we'll start with questions in the chat. All righty.
Okay. Looks like you got one, Alaina, from Paul. How will you incorporate habitat and logging practices into this analysis?
That's a great question. And unfortunately, it is beyond the scope of my research capabilities. However, we do have another graduate student, Annie Oviedo. I'm not sure if she's on, but she will be looking into habitat analysis for parasite infection and survival. So that work is coming. It is unfortunately not being done by me. I do not have that skill set. So I have a direct message from Chuck. Are there methods to control the winter tick? So the current methodology that's being utilized to help control winter tick, and Lee, I'm sure he's on here and he can speak better to this. But the adaptive management hunt is the current task or the current method to control for winter tick populations.
Okay,
I see another.
Yeah, there's another comment or question. Did you try to treat any of the moose you caught and install? Sorry, I'm looking at this. It's going across. I just lost it. Did you try to treat any of the moose you caught and installed collars on with chemicals or sort of things to protect against parasites?
We did not. So we do the same collaring as the state of it's the collaring that the State Department does in January of every year. So at the time of collaring, the animals are not treated with any sort of chemicals to help protect them against parasites. I see another one. District 13.
Diane had one about District 13 not receiving an email about sampling.
Yes, Diane. You should drop your or direct message me your email or reach out to me via email. It might just be that it's bouncing back from that the email on the IFNW list was not correct. So feel free to reach out to me via email and I can send out the links to you. Amber has a good one in the chat, and I'm not sure if Lee is on. But I'm going, I do see Lee's on here. I'm gonna throw the question from Amber to Lee. I don't know if he can. There, Lee, you should be able to unmute now. I made you a co-host.
Oh, there you go. Can you hear me? You got me now?
Yeah, we hear you.
Okay, sorry. Yeah, you had me locked up, so I couldn't respond. But give me the question again. So which question am I addressing?
Amber's asking, would you prefer hunters do not shoot a moose that is collared?
Oh, well, it doesn't matter. It's by definition, any collared moose is legal quarry. There's very few adult cows that have collars still on them. And so it's not an issue at all. And some of the calves that are around this fall, most of them, any of the survivors, they do not have collars on them at this point because those are basically designed to drop off. But there is a possibility where you could shoot a moose and it has a brownish ear tag in them, and that's great. That's fantastic, and that's information that we would love to get back. So if you wind up harvesting a moose that has either a collar or an ear tag, make sure wherever you register the moose that they're aware of that and that they can record that information and get that back to me.
Thank you, Lee. I appreciate that. Another one in the chat from Steve, any concerns with moose pellets stacked to make leather goods? So the moose pellet sample that we're asking for is only going to be a partial pellet. Moose pellets are very large. And so we have a tube with ethanol in it, and part of the fecal sample, part of the pellet will just go in that tube and be preserved in the ethanol. And we only need half of one pellet.
I think the question was about moose pelts
Oh, pelt.
and them back to make leather goods. So that's more about transport across state lines. I'm not sure about that answer, but Lee,
Yeah, that
maybe
might-
you know.
So what's the concern about the moose hide? If you skin out the moose and you want to keep your hide and get a tan or whatever, was there a question about out of state or because there's not, it's all good.
Yeah, I think the question was whether traveling back to Chicago,
Oh,
are there techniques required to bring it across state lines?
no, I mean, if they're gonna skin out the moose and have the hide, of course, they're gonna want to figure out the best way to take care of that. Because it's not a hide, it's, still gonna have some amount of flesh on it and things, and that's not something that you want to get warm. That can become rancid and all that. So I think that's something that if somebody has that interest, they just need to look at the proper way to take care of that so they can travel with it, which might essentially be, wrapping that up and getting that essentially frozen and keeping it in a cold state in order to get it to where their destination is. So if they're talking about the concern about ticks, the thing about ticks during the hunt in October is that you're talking about larval ticks. And, once the animal is shot and it's on the ground and everything, it's brought to the registration station, the ticks are still on it. Eventually those ticks are going to come off, but once they're off the moose, they have no other means to survive. They can't continue on with their life cycles once they're off of a moose. So, I'm not sure the best way you treat that if that was a serious concern, but it's very different than dealing with adult ticks at the end of their tick life cycle in March and April.
Thank you, Lee.
Yeah.
So Henry's asking, do you think a solution to the ticks will be found? When? Anyone working on it? So there are people working on it. The State Department and Lee are on top of it. And they are trying the adaptive management hunt. So we're hoping that is the solution. Time will tell with the adaptive hunt. And Henry asked a follow-up question here. I see, since the moose population is dropping, don't you think there should be a limit on hunting, like lowering the permit quota? And Lee, I'm going to toss that one right back to you because that is your area of expertise.
Yeah, I mean, it's a hard concept for people to understand because, the problem is that we've had too many moose on the landscape for too many years in the state of Maine, and it's all, we compare this to infectious disease like COVID or anything else. When you get more and more people together in the same room, everybody's going to get it, and it's the same concept with moose. And actually, removing the element of moose harvest is absolutely the wrong way to go. And that's not going to help the moose situation. And the other issue is that You know, the moose hunt for the last 40 plus years has been very conservative, and moose hunting, moose permits are not what caused the moose population in the state of Maine to decline or increase or whatever. With all the information we have, the thing that drives the moose population in the state of Maine in the last decade is the impact of winter ticks. What Alaina said was that, you know, ticks affect calves trying to make it to their first year. So we get high mortality there, and then it depresses reproductive rates in cows. So we need to try to turn that around by reducing the amount of winter ticks on the landscape, which is difficult when you're talking about 16,000 square miles of moose habitat, and winter ticks are everywhere in the state.
Thank you, Lee. I see one about anaplasma. So at this point, is anaplasma more detrimental to calf survival than winter ticks? I do not think that is the case, and Pauline and Lee, correct me if I'm wrong on that one. I would not feel confident saying that at this point in time.
Right.
We are concerned with anaplasma playing into the lower reproductive and survival rates, but we do not believe it is the main cause at this point in time.
Yeah, and I think it's important to point out that the work that you're doing, Alaina, and Pauline, and the other folks at Orno, is to try to dig deep and understand how important or not anaplasma is. And at this point in time, we have excellent science that tells you that if you did not have winter ticks and you took away winter ticks, we would not be looking at an 87% mortality rate of our collared calves this last spring. It would probably look like 10 to 20%. It would be completely different. Take away the ticks and you don't have a problem. And what Alaina's showing in previous work at Orno with Pauline and another student was that it looks like when moose have winter ticks and they have anaplasmosis, that they are more likely to die. And so we're trying to figure out, and it's very complicated, how anaplasma may work on moose. And so that's the challenge that Alaina is facing, trying to figure that out.
Yes, thank you. I appreciate that. So Paul asked, will we be collecting moose samples outside of the harvest season? Recent roadkill moose, suspected meningeal worm samples, and if so, should we contact you for sample collection? We would be interested in that, and the state, you should contact the state if you have a moose that's presenting with neurological symptoms. We would be interested in getting samples off of that animal for additional sampling.
Yeah, I'll just add to that, which is, I mean, our department, both game wardens and biologists, are always dealing with on moose that wind up in town or get hit by a vehicle or something, and we do try our best to collect samples, but you're never going to gain a lot from doing that, because by the time we get on a sample, because of warm weather and different conditions and having the right equipment with you, it can be a challenge. But we do look at those things all the time. We keep records on these mortalities opportunistically. We've been doing that for years and years and years, but nothing beats what Alaina is doing, and the whole purpose of this, which is all of you who are being very helpful to provide samples after your hunt, is just really the amazing way to do this. Because as Alaina said, you're looking at really healthy moose, and we want to say, well, is there something that we can see that's wrong with them with anaplasmosis, something that we can detect at a cellular level? And that's very challenging information to get if you don't have this type of work being done.
Yeah, thank you for adding that, Lee. That's really important. Scott's asking, how many years of data do projects are needed to draw definitive conclusions about the impact of parasites, mix of parasites, et cetera, and moose survival? I can't put a perfect number on that. Ideally, we would need many, many years of data. However, a PhD is only about 5 years, so we're hoping for 3 to 4 years of data to show us some strong statistical conclusions. Yeah, but the survival study that Lee and the department have been doing has been happening since 2014. Or a form of it, correct, Lee?
Right, yeah. So, my answer to that question is we have some of the best science on that out of anybody. And your PhD work and the number of years you're doing it um, will be a great data set. I mean, for people to understand, if you're getting 3 to 5 years of data, that's pretty solid stuff. And I think it's going to be very helpful to the department. And again, the hunter harvest surveillance stuff is really top notch, and we're following suit with work that the Minnesota DNR had done with the same thing, looking at hunter harvest. So we're really appreciative of folks and what the university is doing with us.
Yeah. Chuck is asking if we've consulted with Canadian scientists on the winter tick problem, as they have also been researching this. And so, yes, we had a moose research day this summer that Lee so graciously coordinated, where we all got together and shared ongoing research work. And there were biologists from the Canadian provinces present sharing their work. And I'm sure Lee has been in discussion with them as well outside of the moose research day.
Yeah, we work very closely with the Quebec folks. I'm actually an advisor on a research project, a PhD who's doing work in both Quebec and New Brunswick. We're really tied in this together, and we really enjoy being able to talk across the borders. And in fact, we're getting together with one of the moose managers from Quebec this coming week in person to talk more about moose, because that's all we do is talk about moose.
They're a great thing to talk about all the time. So Matt's asking if there's any reason to think having all moose hunters bring the hide out to be collected to reduce tick numbers, and or having the hide burned or buried on site to kill any and all ticks on the harvested moose could help reduce winter tick populations.
It's a great idea. It's one of those ideas that myself and the regional biologists who've worked on our moose research over the last since 2014 have literally responded to and recovered and done several hundred necropsies. And that's in the spring with the adult engorged ticks. And we would love to burn those carcasses, and it would make us feel great. It would be very good stuff to light a fire to them. But, the reality of winter tick and the fact that it's throughout the core range and the amount of winter ticks that's out there, you're not going to put a dent in them. And by doing that, and certainly the number of moose that we harvest in the fall and removing those larvae, which are basically going to be dead anyways. Once that moose comes out of the woods, those larvae aren't going anywhere. They're not going to continue their life cycle. Whether you actively burn that or you just let them drop or whatever, they have no chance of survival.
Yeah, thank you. Drew is asking, how widespread is echinococcus, and is it a death sentence? So unfortunately, my lab mate Tegwin Taylor is not on this call because echinococcus is her wheelhouse, and she would love this question that it's coming up. Do you have an answer for how widespread echinococcus is, Lee?
Sure. Yeah. Well, I have somewhat of an answer. Echinococcus is fairly well spread. There's been a great debate among some of the moose researchers who deal with the pathology side of things as to how much it really impacts a moose. So in other words, what the tapeworm does is it creates a golf ball size cyst in the lung. So what it's doing is it's reducing some of the animal's lung capacity. So if you said to me, is that a death sentence? I'd say, no, it's not. In a particular moose, there may be one moose among many that there's so many parasites that it did not help that moose in the end. Did it kill the moose? That's debatable. Did it add to, was the big mortality factor? In some moose it is, but in many moose it exists. The moose deal with it. They have other lung parasites like the roundworm, the lungworm, Dictyocollis. It just depends on how heavy of a parasite load. And at some point it is going to be detrimental, but in a general statement, it's just kind of adding to the thing, especially if you have winter ticks on you and something like that, driving things. It's a
Yeah,
fact of
great.
life with moose is that, and moose in Maine in particular, that there's a whole spectrum of how parasitized they are. But every single moose is going to have some level of parasites in our state.
Yeah, thank you. And this actually leads into the question Steve asked about wanting heart and lungs returned if possible. If a moose is shot in the heart and lung area, should we aim for the scapula to keep the sample better? Do not change your hunting strategy for our sampling. Always go for the ethical shot and do what is right at that time. We will either not sample that animal or sample around it. So we're asking some hunters to bring in the full lungs and heart. And this is for work that we're collaborating with University of Tennessee on to help answer some of this echinococcus question, to help further develop some tests. So yes, do not change your hunting strategy or the location of your shot for sampling.
Yeah, and that's a great answer, Alaina. And I would say to people that if the shot placement, if it's a shot through the heart and lungs, and it doesn't look too bad as far as the impact, bring it in anyways and let the folks take a look at it. And, maybe one lung is better than the other and they can get a sample from it or a corner of it. I mean, unless it's completely obliterated, if you're willing to make the effort, I think the folks who are there receiving those materials would be happy to take a look at it, and we can make a decision from there.
Yeah, thank you. And so Chuck is asking about looking at a heart, and they found worms in the heart last year. Are the worms another problem for moose? Worms in the heart, Lee.
Well, that's likely lungworm, the dictyocollis, because those lungworms, you primarily find them in the lungs. But that's probably the most likely culprit that was in there. And again, that's the same as we were talking about before. And lungworm, like echinococcus, is one of those debates among moose folks and moose pathologists who say, at what point is the infestation so bad that it's detrimental to the daily operation of that animal? And, we see lungworm in just about every necropsy we do in the lungs. And, at some point it's got to be impactful. But yeah, just another one of those things that moose are dealing with.
Yeah. So yeah, the key take-home message: there are many parasites in moose. Unfortunately, there are many, and I wish I had the budget and time to look at them all, but unfortunately, I don't for one PhD.
Well, and
yeah.
I was just going to jump in on Alaina and say to folks that people also need to understand that these parasites, with the exception of anaplasmosis, are fairly common across moose range across North America. So it's not like, there's other jurisdictions in Canada, upper Midwest of the United States, and in the West that deal with winter tick. There's plenty of places that have echinococcus. There's moose that have lungworms. I think the thing that we're trying to drill home here is that, anaplasma is a player on moose that has not been well documented or studied. And Alaina's trying to understand, is that an impact to these moose and make things worse or not? And the answer to that would lead us down the road of, okay, then what can we do about that, right? And so that's more the unique player here. We have other jurisdictions have meningeal worm. They deal with that in moose. We've had it in Maine for years. Some moose can die from it. Many can live. I don't think it's a big driver for us, but also Alaina is trying to expand the look at that as well, and which is a positive. The more we know, the more we can try to figure out solutions.
Yeah, and hopefully there are lots of solutions out there. And then the last question we'll have time for, Amber's asking if the tooth is only used for determining age. And again, that's part of the department sampling. So Lee, that's on you.
Well, the tooth is a really awesome thing because for you hunters, we're one of the only states that cut those teeth in-house and read the age of your moose in-house and provide that information back to you in the wintertime. There's actually only one company in the United States that does all the reading of all wildlife teeth for all different species for every state agency, and that's in Montana. But they don't do Maine moose. We do Maine moose. So not only does it give somebody the exact age of their moose, but I use that information to look at. So when Alaina was looking at the age distribution, when she showed you of all the animals she looked at, there were so many 1-year-olds, 2-year-olds, 3-year-olds, all the way up to 15. That's really interesting information for us. And we can pull that information together, for instance, with the ovary information and find out, well, what age do cow moose really start to have young, ovulate? And how old are they when they stop producing young? And then when we look at the ages of all of our animals, whether it's bulls or cows, we can also see, well, if we have 13, 14, 15, we have 19-year-old animals in the population, that tells us we don't have a problem in general of what that structure looks like. If we did not have a lot of old moose, that may be a warning sign of something's happening out there that's causing more mortality than we're able to explain, and we have to look at harder. So the age distribution, it's hard for people to understand too, but it really hasn't changed a lot in 40 years, and that includes bulls, and people love to debate this with us as well, but we actually have the data to show that. And Alaina said, the average bull is 4 years old. That's true. But people shoot lots of 5, 6, 7, 8, 9, 10, 11, and older animals. And so it's really one of the more important pieces of information for us to be able to get. And it helps hunters because they love to see how old their moose actually was.
Yeah, thank you for jumping in with that, Lee.
There was a question missed earlier by Mark about the kit. Is there some sort of in the field kit with instructions a hunter receives on hand, conduct a time-sensitive collection in order to send? And I think that was addressed in your presentation, but maybe you want to reiterate the process.
Yeah, we'll end on reiterating that the in the field kit that we're sending out, if you have a 2022 moose tag and you filled out the Google survey, you'll be receiving information from me about that in the field kits that we will ship to you that you should then bring on your moose hunt. And fingers crossed you get a moose, and then you can partake in the biological sampling. So to wrap up here, I see Chuck and Tori have asked some questions in the chat about helping with research. So if you have a 2022 moose tag, filling out that Google survey. If you don't have a tag, talking to people about the research that's happening and encouraging those with permits to participate. And Maine wildlife enthusiasts who may not hunt, what can they do to support the research? Again, talking to people, coming to the webinars, letting us know if you are seeing weird things, reporting animals that are acting strange to the State Department. All of this helps us in our sampling efforts. So I'd like to thank everyone for coming tonight. The webinar was recorded and we will be posting it on our lab website. If you Google UMaine Wildlife Disease Genetics Lab, our lab website will pop up, and we will be posting this for everyone to view at a later date as well. And I'd like to thank Lee and Pauline for being here, and all of you for participating. We had a great turnout, and I really appreciate all of the thoughtful questions and comments. All righty, have a great night, everyone.